Good. I guess we can start. So let me welcome everybody to the 28th edition of the Thesis Award 2020 of the Gustavo Sclocchi Award. Let me introduce myself. I'm Alberto Guadagnini. I'm the director of the Department of Civil and Environmental Engineering of the Politecnico di Milano. And let me start by saying that today's event shines very brightly, at least in my mind, after a very complex year and a half. It seems only yesterday that I was online, and it was a year ago, to introduce and to give my welcome words to the 27th edition of the Gustavo Sclocchi Award. So I'm welcoming all of you, and I'm particularly thrilled and proud to say that I'm faculty advisor of the SPE student chapter at the Politecnico di Milano, and in the context of these activities, we have always supported and encouraged students from Polimi and from other institutions to take part to this prestigious award. The strong collaboration between Politecnico di Milano and SPE has been going on since quite a few years, more than 10 years in terms of research and development. And one of the crowning achievements was in 2017 when the first student chapter at Polimi was established. Since then, like we said, it was history. And we organized together with SPE and quite a variety of events. We are going strong and growing always in terms of numbers and members. And I'm very much excited to welcome all of you today and to congratulate the winner of this edition of this award. I checked a brief preview of the presentations, and I'm very excited to be here and to listen to all of them. So I'm looking forward to it, and welcome again to this edition of the Sclocchi Award.
So good evening also on my side. I'm Alberto Di Lullo. I'm a past chairman of the SPE Italian section and among the guys who originally organized and started this award. So why this award? Next slide, please. Okay, this award has been alive, you see, for a significant number of years. It's entitled to Gustavo Sclocchi, was a former chairman of the Italian section of the SPE, passed away prematurely several years ago. But you see, it's an award sponsored by a number of associations, SPE, EAGE, and Asso Risorse. And so why this award? Okay, this award, because we believe in excellence. We strongly believe that our associated members really should strive in any possible moment towards excellence. But I just wanted to be more precise about this because this is a very important concept for us. We don't confuse excellence with talent. You know, talent is a gift. It's something you received from, from DNA, from random things, from God, from whatever, but it's not a choice. Actually, we believe in a different concept of excellence. That is excellent, as Aristotle said, as a habit of always trying to do whatever we can to do our best job. No? And so if you ask for an example for this, actually we are exactly in the right place. So the award, the Gustavo Sclocchi Thesis Award, has exactly this meaning, to provide to any one of us, examples of really good jobs done during the thesis work of our students or PhD graduates. So it's really for all of us examples of very good activity to be inspired from. So this event is an event of examples of being excellent. And of course, we in the near future, we need a lot more than before excellence, because we are really facing extremely important times, an important decade of great changes for all of our society. So either you are in the industry or you are in academia. In both cases, we really need people devoted to excellence. So now, before starting the nice part of this, which is the real awards, it's interesting for us to listen to the welcome from the main representatives of the three associations which for 28 years have been cooperating to organize this award. That is SPE Italian section, EAGE Italian section, and Asso Risorse. So I immediately leave the floor, the mic, to Paolo Carnevale, the current chairman of the SPE Italian section. Ciao, Paolo.
Ciao, Alberto. Thank you very much, and good afternoon to everybody. So let me talk a little bit about this SPE. SPE Italian section, most of you, I think, know this, but it's one of the European sections of the SPE International, and it is aligned with the mission and vision of SPE International in order to collect, disseminate, and exchange with what is the technical knowledge concerning oil and gas resources and related technologies for the public benefit, and also to provide opportunities to professionals. We also have expanded our vision to be active in supporting a gradual energy transition by promoting knowledge on low carbon energy sources, and also to meet the challenges of the energy business. Therefore, our members include not only petroleum engineers like myself, but also professionals of the whole energy sector. And we are so active in organizing meetings and webinars on decarbonization, energy transition, and industry innovation. So for us, the involvement of the young professional and the networking with students are really crucial elements and are fundamental for the growth of our organization. So the SPE Italian section gives great importance, in particular, to the dialogue with students. And I would like to remind that today there are 3 student chapters at the Polytechnics of Torino, the Polytechnics of Milan, and the University of Rome. And also we gave great importance to the direct involvement of the young professionals, supporting their entry in the business and their conscious awareness of the future of the energy scenarios. And this attention is not coming today, but was particularly important since Giovanni Paccaloni was here together with us. He strongly promoted the young professionals at the international level, and he has contributed to the birth of this Gustavo Sclocchi Award, whose this 28th edition we are celebrating today. And next slide, please. And so I would like also to say that I really thank all the students that they submitted their thesis, and I especially congratulate with the winners for the excellent job. Well done, guys. You really worked hard to complete your studies, and now you are ready to enter in the industry. My recommendation is try not to lose your curiosity, and don't be ashamed or afraid if you don't know something at the beginning. You will understand that there is always something to know, because no one knows everything, and there is for sure someone that can support you. So learn by doing, even and especially when you make mistakes, and you will make mistakes, because this is the right way also to understand from our past. Always try to be proactive, committed, and always challenge yourselves. So I would like also to say to you, good luck to all of you, and again, congratulations for the excellent job. Thank you very much.
It's my time, yeah. I'm Paola, president of the Italian section of EAGE and SEG. And on behalf of EAGE, which is the European Association of Geoscientists and Engineers, I would like to congratulate, I'm sorry, I have to switch on the video. Okay, let me just, okay. Just 1 second. Okay, I would like to congratulate the winners and greet all the attendees to the Sclocchi Award ceremony. of which EAGE has been a sponsor since the beginning. We are an international association for geoscientists, and as we all know, the geosciences have played a central role now and in the past in various activities, from underground exploration to Earth surface monitoring and so on. Among others, the exploration of hydrocarbons has always made extensive use of the geoscience methods for the identification of reservoirs, and in turn this allowed a rapid growth of these methodologies. And several generations of graduates, like me, for example, have worked in these sectors. The world, as Paolo said, however, is changing rapidly, and environmental sensitivity is growing even faster, and new paths are being pursued for the energy production and in the other sectors. Accordingly, our geosciences are called for a change, are changing now to adapt the methodologies to the new technical challenges. I'm thinking about CO2 storage or other, as an example. Exciting scenarios are then opening up for those who are curious, as again, Paul before me said, and the next decades will be for sure full of opportunities for young graduates in geosciences, as long as they are curious, courageous, and willing to change. And I'm pretty sure that you all are part of this new generation. So let me finally invite all of you to become member of the Italian section of EAGE-SEG, EAGE, to be part of the change, to contribute actively to the change. What is going on, we don't know. We have an idea of what the future will be, but we are in some way creating the future in geosciences. And so finally, congratulations to the winners, and thanks again. Alberto, the floor, I think, is yours.
Okay, thank you. So now we should have the representative from Asso Risorse. Unfortunately, Luigi Ciarrocchi just phoned that he could not be present, but he might be joining the event soon. Now we should have Andrea Ketov representing Asso Risorse. Andrea, are you there?
Yes, I'm here. I'm sorry for the delay. I was in another meeting on an emergency, ministerial emergency. Can you hear me? Can you hear me, Alberto?
Fine, very well. We can hear you very well. Thank you.
Well, first of all, let me send you the greetings of Chairman Luigi Ciarrocchi, who could not be here this afternoon, and with us. And I don't know if you have, this is the slide, yes. And we have prepared this slide that gives the participants an idea of what the association Asso Risorse is about, and what are the areas that it comprises. It's Asso Risorse is the Italian Sustainable Energy Resources Industry Association in reality. It is a group of very heterogeneous companies committed to the sustainable development of natural resources. And it's known worldwide for these companies are known worldwide for their strong leadership in designing and operating complex energy projects in challenging environments all over the world. And the association is formed by over 100 companies with highly skilled working force of around 120,000, and they are investing in Italy over €1 billion per year, and they have an export capacity all over the world of over €20 billion per year. So most of its activity is done for export. It's an association that pursues an holistic and very inclusive approach, especially in these times, in order to expand the role of the Italian energy and resources value chain, the whole value chain, in the energy transition that we are all facing towards a low carbon world economy. So here I describe some of the areas that we are more active in through technical groups mostly, and that include hydrogen and include CCUS, includes waste to energy, includes the renewables integration with traditional sources, the recommissioning of EMP installations, and sustainability tools. And so if you students or ex-students now that today receive this important prize are lost in the energy transition, well, you can join us for resources, you can visit us, and you will find resources and technologies and know-how that work together at integrating carbon neutrality and circular economy. So young talents are welcome. Thank you.
So thank you very much, Andrea. Thank you very much, Nicola and Paolo, for your, let's say, kind words and important words with respect to the importance of this type of initiatives. So now we are really getting into the award itself. And so the word is to Marco Brignoli, who is the scientific committee coordinator of this specific activity. So Marco, the floor is yours.
Thank you, Alberto. First of all, congratulations to the winners of the prize of the mention, and congratulations to the students who joined this contest. I'm really proud to say that over the 28 years of its existence, in 2020 marked really the top success of the contest. As you can see from the statistics, we have prepared a couple of slides of statistics. We have we have received this year 70 theses, which is really, for me, most significant results. That despite the hard times we were living, due first of all to the low price of the commodities and the COVID-related all things together in 2019 and 2020, which means that teaching and the science still plays a fundamental role in the development of the activities, of the industrial activity. And even more than the number of the theses, it's good to see the division between subjects of the thesis. If we go to this information, let's look more than the right side on the left side by technical area. We were used to get traditionally theses from subsurface world, geoscience, or G&G, commonly said, engineering theses, which we were basically reservoir drilling facilities. But now, what happened? We can say that a quarter or almost a quarter of the theses received this year related to new resources, new energies, which means, from my point of view, that students and university and research are ready for the transition. So we are happy from an industrial point of view to welcome young engineers, young scientists, young geologists, young whatever you want, to be ready to play a major role in the next year in the energy transition, which we, as oil industry, but not only as oil industry, as society full, we have to live with. That concludes my brief statistic part, and hand back the microphone to Alberto for the next part of the ceremony. Thank you very much.
Thank you very much, Marco. So now I think we are really saying the happy moment of this event. And please, this might be the moment to put a like on the video if you're following from YouTube, and subscribe to our channel. Not, of course, for us, but for the benefit of the students who are later going to make their students graduated now, or philosophy doctors, so that people can follow their presentation later. So now we are really entering into the award ceremony, and so we have our first winner, Giulia Mingardi. Giulia Mingardi in the category of bachelor's thesis and second level master, first prize on pressure and temperature conditions inferred from zircon in garnets from Dora Maira UHP unit, Western Alps. Congratulations, Giulia. You can say a few words now.
Good afternoon. I would like to thank the committee for this honor, and all the three associations. Thank you.
Thank you for your good job. And another first prize winner, Federico Parolin, in the master thesis and PhD category, development of a georeferenced model for the optimal design of a hydrogen supply chain infrastructure. Congratulations, Federico.
Thank you, and thanks to the associations for fostering research in this challenging field.
Thank you for your good job. And the third first prize, Roberto Scaccabarozzi, also in the same category, thermodynamic optimization of the Allam cycle and thermofluid dynamics design of the cooled CO2 turbine. Congratulations, Roberto.
Thank you. I want to thank specifically my colleague Felipe at Politecnico for the support, and everyone. Thank you.
Thanks a lot. And our last first prize to Mattia Martinelli, from outcrop to fracture model, a multidisciplinary approach to characterize fracture networks from outcrop analogs in carbonates affected by extensional tectonics. Congratulations, Mattia.
Thank you very much, everybody. I'm very happy and proud to have received this prize, and I want to thank all the three associations and also all the colleagues that helped me during my PhD thesis. Thank you again.
Thanks a lot. And now we have a number of mentions, because it's before telling the names, it's interesting to say this. You have seen that we started covering a lot of different topics, and actually there are even more. No? You will see how varied are the topics that all follow in the realm of this, in the scope of this Gustavo Sclocchi Thesis Award. And so how many things contribute to what we really need to achieve in the future. So sometimes the choice between the first prize winners and the other thesis is difficult, and we don't want to lose what is really nice. So we have a number of mentions every year. In this case, we have 10 mentions. That's why we gathered them into 3 groups. And so now I will call the 3 names of the first set of mentions, and you can, of course, later say something you wish to say to all of us. So Giancarlo Gentile, thermal and creep fracture analysis of external receivers for solar tower plants. Tiziana Daniele, rock physics modeling experience with focus on seismic inversion time-lapse. Mattia Bonazzi, elastic geobarometry methods validation through synthesis, and characterization of host inclusion pairs by means of Raman spectroscopy. Congratulations to all of you.
Hello, everybody. Thank you very much for the special mention, and it's an honor for me, and congratulations to all the winners. Thank you.
Good afternoon to everybody. I wish to thank the committee for this award. It's an honor for me to receive it, and it strongly gratifies my work on this interesting topic, so thank you.
Hi, everybody. I'm very grateful for this special mention, and congratulations to all the winners. Thank you very much.
Thanks a lot. So the second set of mentions to Daniela Theodore, initial S-wave and P-wave velocity models for full waveform inversion from surface wave dispersion curves analysis. Elena Juliana Kojokariu, I hope I pronounced the name correctly. I'm sorry if I didn't. Numerical dynamics geochemical modeling for CO2 capture and storage, CCS. And Lorenzo Faini, the impact of portfolio players on LNG markets and European gas hubs, an analysis of the last decade.
Good afternoon, everyone. I'm glad to receive this award. I would like to thank the three associations and also the other team members of this project. Thank you again.
Thank you.
Good afternoon, everyone. Thank you very much for this important mention granted by the 28th Gustavo Sclocchi Thesis Award. I am very grateful for the recognition, and I also would like to thank my my ENI tutors for their guidance and their knowledge. Thank you, and congratulations to all the winners.
Thank you.
Good afternoon. I would like to thank the committee and the three associations for this award. I'm very honored, and congratulations to all the winners.
Thank you, Lorenzo. And so the last set of honorary mentions, special mentions. So to Marco Ballarin, power to gas, effect of ultrasonic cavitation on the gas concentration in a liquid. Leonardo Stracca, comparison of object functions for the inversion of seismic data and study on the potentialities of the Wasserstein metric. Alberto Gerri, integration of data-driven classifier trained by adaptive sampling with neural networks for the online prediction of the cool-down time in a subsea pipeline after an unplanned shutdown. And Cristiano Segatori, ducted fuel injection, computational fluid dynamics analysis of soot formation mitigation mechanisms. So also the floor is yours for any comments.
Good afternoon, I'm Cristiano Segatori. I want to thank all the three associations for this special mention. And I want also to thank my colleagues of the current research group at Politecnico di Torino for all the support during my master thesis study. So thank you and bye.
Good afternoon. Thank you for this special mention. It's an honor for me to receive this acknowledgement, and congratulations to all the winners.
Hi, everybody. I'd like to thank all the three associations for this acknowledgement. I'm very proud of it, and I want also to thank my ENI tutor, Dr. Marco Montini, for helping me in during this thesis, and also my supervisors, Dr. Ahmed Shokri and Professor Enrico Zio. Thank you all, and see you.
Okay, great. Thanks a lot. Unfortunately, I mean, this is a moment where it would be very nice to be really together and shaking hands and hugging. We really hope that next year it will be possible. I mean, we are really confident that this will be the case. But for now, we need again probably the last, hopefully, ceremony, such in an online, a little bit cold environment. And now we have a very important moment, which are the presentations, because up to now you have seen what we internally recognized as excellent. Now the winners have the opportunity to show to all of you why we have chosen them, why we believe their work was excellent. So give the occasion to them to really show off what they did. So please stay connected. Sometimes this is difficult because we are entering into technical subjects, but it's a very important moment of growth for all of us. So please go on following all these technical presentations. So let's go on with the first one. Thank you. Probably just a technical moment of loading the presentation. Okay, please, Giulia, start your interesting talk.
So good afternoon, everyone. My name is Giulia Mingardi, and first of all, I would say thank you to the committee for this prize. I am a master's student at the University of Pavia, and for my bachelor thesis, I studied an application of a new approach for constraining pressure and temperature conditions reached by metamorphic rock during their history, the elastic geothermal barometry. I studied a natural case of study, which is zircon inclusions in garnets from metapelites in the Dora-Myra Massif, which is an ultra-high pressure unit in the Western Alps. But what is the elastic geothermal barometry? As I said, is a new approach for calculating the pressure and temperature condition reached by metamorphic rock during the history, so during the subduction and then the exhumation. It is a method that relies on the elastic properties of minerals, so it is different with respect to the classical geothermal barometry, which relies to the chemical properties of mineral. We can explain this method with the first picture. So we can think about an host inclusion system. During the subduction, it will reach a depth corresponding usually to the lithospheric mantle, where at this point we have the entrapment. This is the first step in which the external pressure will be the same pressure as the host, and the pressure of the inclusion will be the same. During the exhumation of this rock pile, we will arrive at a mechanical equilibrium, usually at the mantle crust boundary. And then, at the end of the process, we will arrive at the surface, where, due to the difference in the elastic properties of the mineral, we will have a strange condition. So the external pressure will be the same pressure of the host, but the inclusion will record a residual pressure. It is possible to quantify this residual pressure via Raman spectroscopy, and this is the starting point for calculating the entrapment condition of the inclusion. It is possible to see this residual pressure with stress-induced birefringent halos around the inclusion with the optical microscope, as this second picture shows. I applied this method to an ultra-high pressure unit, in the Western Alps, which is the Dora-Myra Massif. But what is an ultra-high pressure unit? This rock formed at very high pressure within the coesite stability field, so around 3 GPa. And the coesite is a high pressure polymorph of quartz. The coesite is a very important mineral because it is the first mineral that showed us the presence of these ultra-high pressure units in the Alps. In fact, in 1984, Professor Christian Chopin published an article with a very high impact on the scientific community, because he showed the presence of the coesite as inclusion in garnets from the Dora Maira Massif. Nowadays, we know the Dora Maira Massif is not the only ultra-high pressure unit in the Alps. In fact, as I pointed out in the picture, we can see other units very important that are Cignana Lake and Zermatt zone. So for my work, I applied the elastic geothermal barometry to the Dora Maira Massif, especially on zircon inclusion in garnets from the Bostasco-Isaska unit, which is the through ultra-high pressure unit in the Dora Maira. The rocks were the metapelites, and they are characterized by the following mineral assemblage, which consists mainly in garnet, quartz and coesite, pengite, kyanite, chlorite, and chloritoids that are present also as inclusions in the garnets. But other inclusions are micas and, of course, zircon. A thing that I would like to underline is the fact that the garnet porphyroblasts that are present in these metapelites show a clear resonation. So they have a dark core, which is usually crowded with the inclusions, and a lighter rim with few mineral inclusions. And this is the place that I considered most for the application of the elastic geobarometry, because for the selection of the inclusion, we should check the following characteristic. So they should be monocrystalline, isolated from other discontinuities and inclusions, and that's why the rim is a perfect place to find them, and with a size ranging from 10 to 20 microns. So after the selection of the inclusion, I performed Raman spectroscopy on completely buried inclusions. And as we can see in the picture, we can see that the peak that is the peak of the inclusion show a shift with respect to the peak of the standard. This is the starting point for calculating the entrapment conditions, because with this shift, we can calculate the residual strain acting on the inclusion. We should say that we are considering zircon inclusions that are tetragonal. So we are considering only two independent components, epsilon 1 and epsilon 3 of the strain, because epsilon 1 will be the same of epsilon 2. I calculated the residual strain from the wave number changes with a software that our group developed called Strainman, and then all the other barometric calculation from the strain to the entrapment condition with the software that we developed called Entrapped. So I plotted the results on the strain in these two plots, which represent the strain data with respect to the independent components epsilon 1 and epsilon 3. In the plots, we can see the red dots that represent the strain data with their confidence ellipses, so an area where we can find the strain with equal probability due to the error. Then we can see dashed line that are the isocores, so line where the volume strain is the same, a blue line which represents the line of the isotropic strain, so where epsilon 1 is the same as epsilon 3, and the line of hydrostatic stress. As we can see, most of my strain data plot near the blue line of the isotropic strain, but especially in this second plot, we can see a dispersion of the strain along different isocores. Why we have this dispersion? So the strain plot along different isocores for two different causes, or different entrapment conditions, but I did not have the time during my bachelor thesis to analyze this aspect. We are working on it, or an effect of the shape of the inclusion. So I created a model where I analyzed two different shapes, a perfect sphere and ellipsoid with the crystallographic axes that are parallel to the principal axis of the morphology. And I considered a metamorphic condition, which is in this case 4 GPa and 700 degree. And I obtained this result. So as we can see, this is the plot of the model that I used. And we can clearly see that the sphere plot along an isocore and the ellipsoid plot along another isocore. So this model that considers the shapes of the inclusion can explain what we have observed in the natural samples. From this point, I was able to calculate the residual pressure acting on the inclusion. And I obtained a mean of the residual pressure, which is 0.49 GPa. I plotted the residual pressure with respect to their position in the garnet. So I considered the core, the mantle, and the rim. And also here we can see why the shape is so important in my case, because most of the inclusions are at the rim, so they were entrapped at the same condition. And so we have that the shapes is very important for understanding the dispersion along the isocores. But we have a problem here because we have calculated that our inclusions show a very high residual pressure, which is translated to an entrapment condition corresponding to 0.5 GPa and 600 degrees. I plotted my results with the previously published results obtained by Rubato and Derman, which show the metamorphic evolution of the Dora Maira. And this is not a very good news for, this was not a very good news for us, because we can see that my conditions are very low pressure at and 600 degrees for temperature. But the good news is that we compared my results with the results obtained by Campomenosi et al. On the white schist, which are different lithology in the same unit of the Dora Maira, and both of our results show the same thing. So entrapment condition at 0.5 GPa and 600 degrees. We explained this situation with a possible reset of the conditions at this point of the PT PET of the Dora Maira, and we are now working on it. So in conclusion, my work represents the first application of the elastic geobarometry to the metaperites from the Brusasco-Esasca unit in the Dora Maira massif. We have seen that the dispersion of the strain along different isocores is probably due to the effect of the shape of the inclusion. And my results provide an evidence of a general post-entrapment elastic reset of the host inclusion system along the retrograde path of the Dora Maira massif near 600 degrees and 0.5 GPa for pressure. And my results are consistent with the white schist data obtained by Campomenosi et al. 2021. Thank you for the attention.
Thank you very much, Giulia. I think that there is the opportunity for a question, of course, among the participants to the inner, let's say, Cisco WebEx meeting. But if you want to make a question, I think there is time for one. Not necessary, but when we did this in person, it was typical, no, for people to have questions. But here it's more difficult.
It's more difficult. Yeah. Thank you.
Okay. In any case, thanks a lot.
Thank you.
Physical virtual clapping. Okay. So we can switch to the second winner. The usual technical moment of PowerPoint loading. Good. Roberto Scaccabarozzi, please, your presentation.
Okay. Now I should be able to change slide. Yeah. Okay. Good afternoon, everyone. I'm Roberto Scaccabarozzi. I'm a research fellow at Politecnico di Milano, and I will present my PhD thesis titled Thermodynamic Optimization of the Allam Cycle and Thermofluidodynamic of the Cool CO2 Turbine. The carbon capture and storage is a process that allows the removal of CO2 from a stream in order to stock it for a long period of time. And according to the scenarios of several international energy agencies, it will play a significant role in the transition to a complete renewable scenario in the power generators. The state of the art of carbon capture of carbon capture from natural gas power system is the amine-based. You can change the slide. Okay, that's working. Natural gas power system is the amine-based chemical absorption process. It is a post-combustion configuration with low concentration of CO2 in the flue gas and has a high performance penalization. The higher is the carbon capture level, the higher is the performance penalization derived from the carbon capture system. On the other hand, the Allam cycle is a semi-closed intercooled regenerative oxy-combustion cycle using CO2 to moderate the flame temperature. First, the working fluid is intercooled compressed up to supercritical condition. Then it is pumped to maximum cycle pressure and it is split. Part is mixed with the oxygen provided by an air separation unit to produce the oxygen stream. Part used as coolant in the expander, and the remaining part is used to moderate the flame temperature. All the streams flow through the regenerator and are preheated. Then the oxidant and the temperature moderator are fed to the combustor with the fuel and exit at around 30 megapascal and above 1350 Kelvin. The stream is expanded down to 3 megapascal in the cool expander, and then it flows through the outside of the regenerator, providing it to the cold stream. Finally, the condensation, the water is completed, and the water is removed, and a small fraction of the stream is sent to the storage. This is the temperature-specific entropy diagram of the cycle, generated considering pure CO2 as working fluid. At the bottom, there is the intercooled compression with the injection of the oxygen. Then in light blue is the cold side of the regenerator, the combustor in red, the cooled expander in orange, and finally the outside of the regenerator and the condenser in yellow and green. According to the inventor, it is possible to reach 60% net electric efficiency with the reduced capital cost and a simple layout, and without any kind of emission, both of CO2 and pollutant. An independent study of the EAGE-SEG partially confirmed the claims of the inventor, comparing the Allam cycle with 3 other oxy-combustion cycles. The results show that the Allam cycle is the best option, both from an efficiency and cost point of view. The main design challenges of the Allam cycle are related to the high temperature, high pressure components, the combustor mainly to the flame stability and ignition, the regenerator due to the high transfer area, the superalloy for the high temperature operation, the corrosive behavior of the condensing water CO2 mixture, and the high pressure difference of the stream. Finally, the turbine, because it is a first-of-a-kind machine with unknown design criteria, the mechanical resistance of the parts is challenging, and again, the corrosive behavior of the working fluid. 8 River Capital is building a 50 megawatt demonstration plant in Texas, aimed at testing the component and actual operating condition, collaborating with Toshiba, which is providing the combustor and the turbine, with Atric, which is providing the regenerator, and the air liquid, which will provide the oxygen by a nearby air separation unit. The objective of the thesis assess the maximum achievable efficiency and operating condition of the Allan cycle and perform a techno-economic assessment of the technology. Study the preliminary design and performance of the expander. Assess the operational flexibility and the cycle of the cycle, analyzing the partner control strategies, and develop a new cycle configuration, coupling it with a solid oxide fuel cell to further increase the cycle performance. So, the optimal operating condition of the Allan cycle reach a net electric efficiency of 55.2% with a turbine inlet pressure and temperature of 29 megapascal and 1400 Kelvin. On the right side of the slide, you can see a chart depicting two sensitivity analysis on the maximum allowed turbine outlet temperature and on the maximum turbine inlet pressure. The highlighted point is a promising configuration which is able to achieve close to optimal performance while reducing the temperature operation of the regenerator below 1000 Kelvin and thus reducing the investment. The sensitivity analysis show that the most critical assumptions are the minimum cycle temperature, which affect the performance more than a conventional combined cycle. The minimum temperature difference within the regenerator, which highly affect the investment cost. The air separation unit specific power consumption, which is the main auxiliary of the cycle, and the effectiveness of the turbine cooling system. The techno-economic comparison with the reference case of the combined cycle with and without CCS, and the second most promising oxy-combustion cycle of the IEA report, the Sclocchi cycle, show that the Allan cycle remains the best oxy-combustion option and show a cost of electricity and CO2 avoided less than 10% higher than the actual state-of-the-art technology. So the Allan cycle with optimal operating variables can achieve a net electric efficiency of 55.2% and accepting a performance penalization of 0.3 percentage point allowed to reduce the maximum operating temperature of the regenerator below 1000 Kelvin. Finally, the higher efficiency and low carbon emission allow to achieve electricity and CO2 avoided cost only marginally higher than the state-of-the-art technology. Moving to the turbine, the Allan cycle turbine is a high temperature machine with an inlet turbine temperature above 1350 Kelvin, high mechanical stress and small volumetric flow rate due to the high density of the working fluid. And furthermore, the rotational speed is fixed by the electric grid and it is affected by small temperature changes in the working fluid and thus a high number of cooled stages. The design problem is a multidisciplinary problem that has to tackle simultaneously the fluidodynamic, mechanical, and the transfer problem. Furthermore, there are no guidelines to design such a first-of-a-kind machine. Thus, the objective is to develop a simplified methodology to assess the turbine design, its performance, the cooling flow requirement, and their impact on the efficiency. The developed methodology is a row by row iterative procedure which divide each row in two sections, the blade row and the blade row gap. In the first section, the mainstream is mixed with the film cooling fraction of the coolant, and in the second, with the remaining part of the coolant. In both cases, the outlet condition of the mainstream are computed performing energy, mass, and momentum balances. The results show that increasing the number of stages from 5 to 6 allow increasing the expansion efficiency of 1 percentage point, while increasing the investment cost, obviously. Using a front-load configuration and increasing the flow coefficient throughout the expansion is beneficial. And compared to conventional gas turbine, the fin cooling technology is less effective, and the overall cooling flow requirement of the alarm cycle is smaller. Moving to the control strategies for from all the possible combination of operation modes and constraints, 4 different part load control strategies combining partial and full emission turbine with constant and variable minimum cycle pressure are considered. The results show that it is always advantageous to have a variable minimum cycle pressure. Indeed, the orange line is always above the blue one, and the yellow line is above the gray one. On the other hand, the optimal strategy for partial admission turbine is to have full admission above 60% load. Indeed, in the chart, the yellow and the orange line coincide as the gray and blue one do. While below 60% load, it is advantageous to reduce the admission arc of the turbine. Concluding, reducing the minimum cycle pressure and the using partial admission turbine have a positive effect on the cycle efficiency when the load is below 60%. Furthermore, using a partial admission turbine is the only way to reduce the load below 30%, achieving better per load performance and turbine capacity compared to a conventional combined cycle. Finally, the main goal of the hybrid cycle scheme is to increase the net electric efficiency of the plant while reducing the operative temperature and thus cost of the regenerator. The objective are achieved adding a soft unit before the combustor. In this case, the oxidant stream, after being preheated in the regenerator, is fed to the cathode side of the fuel cell, while the anode is fed with a mixture of fuel and recycle from the anode. The optimal point reach a net electric efficiency of 75.7%, featuring a soft operating pressure of 40 megapascal. And as previously mentioned, the turbine outlet temperature is significantly lower compared to the standalone configuration of the cycle, decreasing from 1000 to 800 Kelvin. In this slide, the chart on the left shows a sensitivity analysis on the combustor outlet temperature and cycle maximum pressure with fixed fuel utilization factor at 0.85. This analysis shows that even with less challenging operating conditions, the plant is able to reach an efficiency above 73%. The chart on the right shows a sensitivity analysis on the maximum cycle pressure and the fuel utilization factor for a cooled and uncooled turbine with fixed turbine inlet temperature. The analysis showed that reducing the fuel utilization factor has a higher negative impact on the cycle performance when the maximum cycle pressure is lower, due to the lower efficiency of the bottoming Brighton cycle. So, concluding, the proposed hybrid configuration of the alarm cycle featuring a solid oxide fuel cell is able to achieve a net electric efficiency of 75.7% without any operating conditions. On the other hand, the cycle can be designed with less challenging conditions while keeping a net electric efficiency above 73% or 68% with an uncooled turbine and lower fuel utilization factor of the fuel cell. Thank you for your attention. Again, thank you for the award.
Thank you very much, Roberto. So one communication, we introduced just below the video a form to make a question, if you like. Of course, they could be passed real time, but if you wish to place them in any moment, we can of course pass to the winners and have them replied later. I would have a question for you, myself, which is this one. Now there is an acceleration, a strong acceleration in having available low carbon technologies. But actually, the alarm cycle has been under development for a number of years now. Now it's in pilot stage, and we know there are difficulties, and you explained number of them. What do you think is the proper, let's say, time frame in which a technology like this can be developed from the idea to industrial application? What is the time it normally takes to achieve this?
Well, it is difficult to answer. The higher the challenges, the longer it takes to develop the technology. But I think that according to what I know about the cycles, it will take again a couple of years to reach the stable operation, I think, of this technology, at least. And disregarding the hybrid configuration that I presented, the problem of that configuration is the pressurized solid oxide fuel cell, which is really challenging, and I'm not sure that will be available soon.
Yeah. In any case, it normally takes years. No?
Yeah.
So okay. So thank you very much, Roberto, again. Applause to your very nice presentation. And I think we can pass to the third winner. And remember, if you want to, remember that you can put a like under the presentation, and in any case, you can ask for questions at any moment, and we will try to have them replied. So this presentation is from Federico Parolin, development of a georeferenced model for the optimal design of a hydrogen supply chain infrastructure. Please, Federico.
Yes, thank you. I'm Federico Parolin, and I will give an overview of my master thesis, development of a georeference model for the optimal design of a hydrogen supply chain infrastructure. Okay, now I have the control. Okay, so in 2019, the European Commission issued the European Green Deal, according to which carbon neutrality must be reached by 2050. It is clear that such an ambitious target requires to take actions in all the sectors. And within this framework, hydrogen is expected to play a crucial role as it finds applications in various sectors. Here, the most interesting applications are reported. And as you can see, they involve the power, the mobility, the industry, and the building sector. However, the widespread use of hydrogen is currently hindered by the absence of dedicated infrastructure that allows distributed access to this energy vector. And within this framework, the objective of the thesis is to develop a tool to optimize the design of the entire hydrogen supply chain. So when modeling the hydrogen supply chain, common simplifications that are introduced in the literature are to impose the selection of the transport modalities, to consider a snapshot, so a time invariant analysis, and to adopt a schematized spatial description not based on actual geographic data. So having identified these research gaps, the objective of this work is to develop a model that optimizes the selection of the transport modalities, that considers a year-long analysis, and that is integrated with a geographic information system for the spatial description of the supply chain. The developed model considers the production of compressed or liquid hydrogen via either natural gas reforming or via electrolysis systems fed by solar photovoltaic. The included transport modalities are pipelines, compressed hydrogen trucks, and liquid hydrogen trucks. And accordingly, the storage can be performed in pressurized vessels, in cryogenic tanks for liquid hydrogen, and in the trailers of compressed hydrogen trucks. As for demand, the produced hydrogen is here assumed to be exploited by mobility, which implies that refueling stations are the final element of the supply chain. The spatial modeling of the infrastructure has been addressed by including detailed spatial data of the GIS type. And this is essential to obtain a realistic description of the infrastructure, since each stage of the supply chain is subject to geographic and territorial constraints. So the candidate distribution networks are built on the basis of GIS data, which are available in the shapefile format, thus requiring a proper conversion. The developed methodology is here presented, referring to the case study of Lombardy, to which the complete model will be applied. So the candidate road distribution network is built on the basis of the existing road infrastructure, while it is assumed that pipelines can be installed following the existing railroad network, since it identifies areas where a right-of-way already exists. Then the position of refueling stations is identified considering the existing gasoline and diesel stations, assuming that 10% of them will host hydrogen refueling. While for production, reforming plants are assumed to be located at the refineries of Pavia and Mantova, and the electrolysis sites can be installed at the province's centroids. So once defined these input data, the developed methodology, which is here summarized, allows to convert the input shapefiles into directed graphs upon which the optimization model is based. The optimization model aims at minimizing the average cost of hydrogen delivered to refueling stations. And the complete description of the infrastructure requires the definition of 4 types of nodes in the model, and they are production, intermediate storage, demand, and transit. As far as the temporal description is concerned, a year-long analysis is considered, adopting a daily resolution, and in particular, 52 typical days are identified, and each of them is repeated 7 times in order to build the 52 weeks that constitute the year. In this way, it is possible to maintain a daily resolution while working with only 52 time steps instead of 365. The model was implemented in MATLAB, exploiting the YAML toolbox and the solver Gurobi, and following the mixed integer linear programming formulation, which envisages the co-presence of continuous and integer variables. Besides the network's topology, the model requires to assign the demand and PV generation profiles, as well as the production and storage capacity limits. Then the infrastructure is optimized at each node and edge of the graphs in terms of the exploited transport modalities, of the installed production and storage capacities, of the hydrogen flows, of the exploited transport pathways, and of the transported quantities. This slide shows a schematization of the hydrogen pathways in the model. So as a consequence of the spatial modeling, there are 2 graphs, one for road transport and one for pipeline transport, while hydrogen sources and sinks are unique. According to the model decision logic, which is here schematized in a block diagram, the first selection that the model requires is that of the spatial scale in terms of the geographical region to study, and therefore of the shapefiles to employ, which are then converted into directed graphs representative of the candidate distribution networks. Then the model requires to select the transport modalities to include in the simulation. since it is possible to perform both monomodality and multimodality simulations. And similarly, it is possible to include or exclude the production from refineries or the import of grid electricity to feed the electrolyzers. Once these input choices are defined, the model optimizes the infrastructure according to the previously presented modalities. The model has been first tested and validated on a simplified topology, which allowed to test and introduce a set of adjustments aimed at improving the model computational performances. And in this way, it was possible to scale up the model to the regional case of Lombardy, for which multimodality simulation is completed in about 40 hours. In the definition of the case study, the year 2050 is considered as a reference. And in particular, it is assumed that hydrogen-powered vehicles account for 25% of the passenger cars stock share, which is reflected on an annual demand of 145 kilotons. The annual evolution of the demand is then computed on the basis of traffic data. Considering then production, it is assumed that the maximum dedicated PV capacity that can be installed to power the electrolyzers for each province is equal to 5 times the currently installed capacity. While for refineries, it is assumed that maximum 20% of the hydrogen production will be exported for clean mobility. Results show that the cost-optimal infrastructure relies on the parallel use of all the included transport modalities, reaching an average cost of hydrogen of 5.83 euros per kilogram. In particular, pipelines and liquid hydrogen trucks are each responsible for the supply of 47% of the stations, while the remaining 6% receive compressed hydrogen delivered via truck. In the middle, the distribution and capacity of the installed production plants are reported, while the total investment required for the infrastructure realization amounts to 6.1 billion euros, which is high but does not appear unbearable, considering that over 20 years, the annual impact on the region's GDP would be lower than 0.1%, and considering also the positive effect that it might have in terms of value added and of job creation. This slide shows the exploited distribution networks for the included transport modalities. So having to supply most of the stations, the pipeline and the liquid hydrogen trucks networks are very extensive, while the road network exploited by compressed hydrogen trucks is more restricted, confirming that this transport modality is suitable for small delivery requirements. The installed pipelines have a diameter lower than 30 centimeters, even though these results are optimal for the assumed demand, and during an actual installation, the sizing could be larger in perspective of future demand increase or of other hydrogen uses. This chart shows the cost of hydrogen reached by stations, considering them separately according to the transport modality that supplies them. So the highest cost is reached by the stations that receive liquid hydrogen trucks with a value higher than 7 euros per kilogram, while the lowest cost is achieved by stations supplied via pipeline with a value of 5.20 euros per kilogram. The chart also shows that the transport cost contribution is mainly due to pipeline installation, and that the intermediate storage costs are related to liquid hydrogen only, since it is the only modality for which intermediate storage sites are exploited. The greatest contribution is definitely the one of production, for which PV installation costs account for more than 40% of the overall production expenses. So to conclude, besides the results, the developed model represents a tool that could help decision makers or industrial players to evaluate the adoption of hydrogen. And thanks to its characteristics, it allows to obtain a higher level of detail with respect to what can be found in the literature. The application of the model to the case study of Lombardy allowed to show that in this region, an average cost of hydrogen of 5.83 euros per kilogram is reached, with an overall investment of about 6 billion euros, corresponding to 1.6% of the region's GDP. And the application also proved the relevance of the multimodality formulation and of the integration of the optimization model with detailed spatial data. In terms of future developments, it is interesting to evaluate the inclusion of additional storage and transport technologies so as to widen the comparison, or to apply the model to other hydrogen end uses, like, for example, considering the future hydrogen demand of the industrial sector. An alternative path, which is also interesting, is to pursue the improvement of the model computational performances with the ambition to apply the model first on the national scale and then even on European scale. So thank you for your attention, and I hope the presentation was interesting.
Thank you very much, Federico. Yes, it was absolutely interesting. Thank you for contributing to understanding the future hydrogen market, which is something of great relevance. I think we can actually skip the question a moment, because of course you can in any case write them down, and we can now switch to the last presentation of the winners. So thank you very much, Federico Parolin. Great. So now, Mattia Martinelli, the floor is yours.
Thank you. Good afternoon, everybody. I'm Mattia Martinelli, and today I will present to you the main result of my PhD thesis with the title "From Outcrop to Fracture Model, a Multidisciplinary Approach to Characterize Fracture Networks from Outcrop Analogs in Carbonate Affected by Extensional Tectonics." Okay, now I should have the control, I think. Okay. So my PhD project was inserted inside the CEFRAC project funded by ENI. And the main aim of this project was to improve the fracture network characterization and modeling in fractured carbonate hydrocarbon reservoir in different tectonic environments using outcrop analogs. And in particular, my PhD project was focused on the extensional tectonics environments. So why do we need outcrop to model or to improve the modeling of fracture network? Basically, because as we can see here in this picture, there is a gap between well data and seismic data. And the use of outcrop model can help us to fill this gap. As a case study or study area, we choose the Malta and Gozo Island. Okay, here. The Malta and Gozo Island that are located in the foreland of the Apennine Sicilian Mangabian belt. And these two islands are characterized by the presence of a late Oligocene, late Miocene stratigraphy composed by different types of carbonates. We can see here the 6 main stratigraphy, the stratigraphic units, so the lower coronary limestone, the Globigerina limestone, the blue clay formation, the green sand, and the upper coronary limestone. And moreover, we can see that there are some Neptunian dikes in the lower units associated with small normal faults. Moreover, more important for our project is that the two islands are characterized by the presence of two sets of normal faults trending west-northwest, east-southeast, and east-northeast, west-southwest. So we decided to apply a multidisciplinary approach that brought out from the tectonic evolution of the island to, at the end, to realize a small DFN model of the fracture network. And we will see the 4 main topics in detail. So we can start from the first one, from the tectonic evolution. To characterize it, we collected different types of structural data, from fault altitude to fault kinematic indicator, in 14 different outcrops in both Malta and Gozo. And these allow us to recognize the type of set and also the faults present. So as I said before, we found 2 main sets of normal faults associated with 4 sets of joints that you can see here below. And moreover, we recognize also the Neptunian dikes associated with small normal faults. So bringing together also the relationship between the faults and the dikes and the joint, we were able to recognize the relative chronology of the structure. So basically you can see that the big fault, so the 2 main set of normal faults and the joints are present in throughout all the stratigraphy, while the Neptunian dikes and the associated small normal fault are present only in the lower units. And this testifies that Neptunian dikes and this small normal fault were formed in an older events with respect to the other tectonic structures. So in particular, we were able to say that from the late Oligocene onward, the Maltese Island underwent 2 main tectonic events. The first that we call D1 between the late Aquitanian, early Burdigalian, then led to the formation of the Neptunian dikes and associated normal faults with a west-northwest, east-southeast extension. Then we had a period of tectonic quiescence with no deformation. And then from the Messinian onward, the deformation started again with a north-south extension that led to the formation of the main faults of the 2 islands. We also tried to insert this interpretation inside the geodynamic evolution of the Mediterranean. And we can see that during the late Oligocene here, during the deposition of the lower coronary limestone, we had a trench that was moving to our south with a slab that was rolling back. And this rollback in the Aquitanian, early Burdigalian, brought the trench really close to the Maltese Island, so caused deformation due to the slab rollback and caused the first event of deformation. Then from the Aquitanian to the Messinian, the slab rollback cheesed, and cheesed also a deformation on the Maltese Island, as testified by the absence of deformation structure in the units that was depositing. Then at the end, from the Messinian, the slab rollback started again, this time with a south direction. And this caused the starting of the second deformation event that was a north-south extension and create the main faults of the 2 islands. So the main conclusion of this first part is that from the late Oligocene to the Pliocene, the Maltese Islands underwent 2 main deformation events divided by a period of tectonic quiescence. and we interpret both the extinctional events as caused by the foreland flexure and slab rollback. Now that we reconstructed the tectonic evolution and also the fault and fracture type on the two islands, we can concentrate our attention on the fracture parameter characterization. And we decided to characterize the fracture parameters and in particular the effect of the normal deformation on the fracture network on the Gozo Island, and in particular on the Cala fault, that is a fault that is located in the eastern part of Gozo. And in particular on this fault that we call the Cala 2 fault, that is a small fault with 30 meters of displacement, so not a very big fault. But this outcrop is really interesting because here the lower coralline limestone, as you can see here, is outcropping and visible for almost 1 kilometer. So we were able to characterize the evolution and the fracture parameters from the fault zone to the background. And on the field, as you can see here in this sketch, we were able to recognize a highly fractured zone close to the fault, and then a wide but less damaged area, almost 800 meters long here, that we call outer damage zone before the background. To characterize the fracture network here, we applied a new method that requires two steps. The first step requires to apply a linear scanline on the outcrop to basically characterize the spatial distribution of the fracture network using statistical analysis. And this is important because it allows us to define some homogeneous area. As you can see here, we have a fracture uniformly distributed. Here we have a fracture corridor. Here we have randomly distributed fractures. And then once this area was identified, we applied scan area on this area to have statistical valid information to extract the main fracture parameters, so density, intensity, length, spacing, and topology. Of course, this type of analysis performed directly on the outcrop will take too much time. So we decided to create a digital outcrop model with a photogrammetric reconstruction. So we reconstruct a dense point cloud with drones. We then extract an orthophoto, and then we interpret the fracture network on the orthophoto. We then imported our interpretation and our digital outcrop model inside SquagoCAD, that is a 3D model software that has a plugin that allows to write Python script. So we wrote original Python script to be used into this software to automatically basically apply this linear scanline analysis. And you can see here an example of the joint set is northeast, west, southwest. Thanks to the linear scanline analysis, we recognize the presence of 4 fracture corridors intercalated from fracture randomly distributed. So then in the scan area analysis, we will apply a dedicated scan area on each fracture corridor. Then the other 2 joint sets, the west, northwest, east, southeast, and north-south, were only randomly distributed with no fracture corridor. We did not investigate the yellow fracture set that is the northeast, southwest, because there were too few fractures. Now that we individuated this homogeneous area, we can apply the scan area analysis. And one question is, which is the right dimension of the scan area to have statistically valid information about the fracture parameters? So we decided to use the representative elementary volume that basically it works in this way. When we are measuring a property and we start to sample it with a volume or an area, with a small volume, the property oscillates around the mean value. But when we reach the representative elementary volume, this property tends to stabilize without a mean value. So we wrote, again, some Python script to be used inside the GoCAD. And we found that for the density and intensity, and also for the other parameters, the set is northeast, west, southwest scan area should be 400 square meter or more. For the second set, 900 square meter or more, and for the set north-sud, again, 400 square meters. Then we apply on our digital outcrop model the scan area to characterize the evolution. As you can see here, we have the fault, and then the outcrop. You have to imagine the outcrop here that we are moving away from the outcrop. So basically, we were able to characterize, here in this slide, you have the density and the intensity, but we also characterize length and spacing and trend. But we will speak only about density here, only for an example. You can see here that we have the inner damage zone that we characterized at the beginning. And then you can clearly see that the density in this set remain constant until the background is reached, if we, of course, exclude the fracture corridor that are this red area. We also perform another type of analysis that was the hydraulic connectivity using the topology, so determination type of the fractures. And using this equation, it is possible to estimate the hydraulic connectivity. If the result of the equation is above 0, this means that the fracture network is connected. Otherwise, it means that it is unconnected. So you can see that our fracture network is connected in an area of 100 meters from the fault zone. That is quite a big area. If we think again that we are dealing with a small fault with a small displacement. So to conclude this part, we recognize that in the Cala fault, the damage zone structure were divided in an inner damage zone, only 5 meters thick, and then an outer damage zone, more than 500 meters thick, where the average parameter remains stable if we exclude, of course, the fracture corridor. But for me, the most important thing is that we demonstrated that even fault with a very small displacement can be surrounded by a relative large permeable damage zone that is really important for the fluid flow. We can move to the third topic. So we try to understand why this small damage zone has a very big damage zone. So this small fault has a so big damage zone. So we go to try to identify if there is an effect of the mechanical stratigraphy. So if we go on the field and we observe the lower coralline limestone and the lower globigerina limestone, we can see that the lower coralline limestone is characterized, as we see before, by a very large damage zone, while the lower globigerina is characterized by a damage zone that is only present very close to the fault zone. So to explain this behavior, we perform a complete petrophysical characterization with porosity, permeability, and density, but also a geomechanical analysis with Brazilian uniaxial and triaxial tests that allow us to reconstruct the complete failure envelope of the lower globigerina and of the lower coralline limestone. And what we can see is really interesting, because we see that the lower coralline limestone is stronger with respect to the lower globigerina, as you can see here from the uniaxial compressive strength. But the Young modulus is higher in the lower coralline limestone, while the Poisson ratio is similar in both the formation. So we used the information from the petrophysical analysis and from the geomechanical analysis to perform a numerical modeling with this layout. It's a 2D final element model. Of course, we have the lower coralline limestone and the lower globigerina. Above and below, we have a weak material to allow the deformation. And in the middle of the model, we put a weak point to localize the deformation and to allow the formation of the fault. We apply 2 steps. In the first step, we apply the vertical stress with the kinematic boundary fixed to simulate the overburden. And then the second step, we start to move the lateral boundaries in order to simulate the extension that is the second extension event that we saw at the beginning of the presentation. And the result is very interesting. You can see here what we have is the two formations, so the lower coralline limestone and the lower globigerina. And as proxy of the deformation, we use the plastic strain that is basically a scalar value used to represent the inelastic deformation of the rocks. So when it is 0, we do not have fracture. When it is start to be above 0, we are starting to fracture in the formation. So we start the extension, as you can see here. And the interesting thing is that if you look at the more cycle, you can clearly see that in the lower coralline limestone, the sigma 3 decrease faster with respect to the lower globigerina. And this is due to the different elastic properties of the two rocks. Indeed, the Young modulus is very different, while the Poisson ratio is similar. This means that the lower globigerina that has a lower Young modulus can expand laterally, more laterally with respect to the lower coralline, and this creates a pressure that goes in the opposite direction with the sigma 3, and this avoids it to decrease too fast. And this is the reason why the lower coralline limestone broke before. As you can see here, we have green color. This means that the rocks is fracturing, while the lower globigerina is still completely intact. And then the fault.
Sorry,
yes?
I need to ask you to proceed towards the conclusions.
Okay.
Thank you.
Okay, so you can see that the folds start to propagate, and then the globigerina limestone basically remain intact with only a small damage zone around. So I go very fast to the conclusion. I have a very 2 minutes. So we try to also to understand how to use outcrop data to build the FN model at the ref scale, because when we are dealing with outcrop well data plus well data, we can characterize better the fracture network. But when we try to put this information inside the FN model, it's impossible to model all the fracture at the reservoir scale. So we can try to model the fracture network in a smaller volume, and this volume can be the representative elementary volume that we saw before. So basically, the idea is that if we use the REV that we saw, that we the representative elementary volume that we characterized before in the outcrop, we can create several DFN model at the representative elementary volume scale, creating an histogram of the property, in this case the density, and use this histogram to populate the reservoir instead of running a complete DFN model of the reservoir. So this can help to reduce computation time, and also it's something that we didn't study, but it can also help to perfectly honor the fracture connectivity and topology. So to conclude, the general conclusion of this thesis is that the use of outcrop analogs is fundamental to better characterize and model fracture network parameters and their impact on the fluid flow in the subsurface. And outcrop analogs allow to investigate the fault and fracture network at different scales and to apply a multidisciplinary approach that allows carrying out different types of analysis that are impossible to perform with borehole and seismic data only. And thank you for your attention.
Thank you very much, Mattia. Again, really congratulations for this work. And this is bringing us Of course, I mean, if any one of you wants to make question, you can do it on the YouTube channel. So we will later pass the questions to the authors. And this is bringing us to the end of this ceremony. Something that I just wanted to highlight is the work of the scientific committee of the evaluators. You may have noticed how varied these topics are getting, and more, of course, while we are entering into renewables and economic factors and the new economies and new energies and so on. And so really the scientific committee is making a huge effort to evaluate these theses, and is involving a lot of specialists. So really congratulations also to the scientific committee, beyond, of course, the winners and all the participants who, of course, did in most of the cases a very, very good job. So the choice is difficult. At this point, I need only to tell you bye-bye, so that we can meet again in person this time, of course, hopefully at Polytechnic of Milan. Now, if we all want to turn on the video, we might have a nice picture of all of us greeting anyone. So if you are available, please turn on the video. And Gaetano will be able to make a snapshot of all of us saying bye-bye and cheers to all the attendants. So some of us are still missing. Gaetano, you are
okay, it's fine.
Yourself.
Okay, it's fine.
Switch on the video, Gaetano.
Gaetano likes privacy.
Hear me?
Good.
Okay. I tried to.
So congratulations to all of you, and see you next time.
Great. Ciao.
From my side. Ciao. Bye.
Ciao.